Welcome to our tutorial, which will tell you about the Calo Indet Method, an evaluation method for true surface properties, which combines calotte grinding and indentation tests. This method was developed by the Saxonian Institute of Surface Mechanics and runs automatically in the software package FilmDoctor. And this is really a global novelty. The Calotte module is the only tool in the world with which you can determine a true realistic profile of the material's properties instead of only taking average values. Thus, you will get profile pictures of the different properties such as Young's modulus, yield strengths, and residual stresses of whole material combinations like coated surfaces, treated surfaces, laminates, and all kinds of inhomogeneous structures. But before we are going to explain more details, let's step back a little and ask, why do we need this method? And what is the aim for nearly every product on the market? The answer is simple. We want to optimize the materials and material combinations in order to increase the application performance and reach specific goals. This might be reduced fuel consumption, carbon dioxide emission, or lifetime predictions even at the edge technology like nuclear fusion. The problem we face is that structures are getting more and more complex. On your mobile screen, for example, you normally don't have just a single glass foil, but a glass substrate with up to 20 layers on top to protect it from scratching, reflection, cracking, and so on. In some cases, we even have hundreds of layers in order to achieve smooth transitions and functional gradients. With these complex substrate layer combinations, personal experience and rules of thumb are no longer enough. You need mathematical tools at hand. Computers and reliable testing models, together with generic material parameters, need to be considered. Quite some years ago, the Saxonian Institute of Surface Mechanics therefore has developed a feature portfolio called OptiCycle, which is a combination of different software tools to design an appropriate measurement test, analyze the experimental data, simulate an application, and finally help to optimize the structure of the substrate layer combination in question. But here again we face a problem, namely that for multi-layers and gradients, we very often are not able to access important material information at every point of the non-monolithic material. Therefore, the Saxonian Institute of Surface Mechanics already has very useful tools on the market. The Standard Analysis Method module, Oliver and Farr for coatings, for example, brings effective values for hardness and Young's modulus, even for inhomogeneous materials with gradients and multilayers, as well as for time-dependent material behavior. But even this might not be sufficient for very complex material combinations. The problem is that I can't get these properties from here, nor here, nor here, if I only look and press on the material stack from the top. You might have determined the properties for each layer during the production process already. Well, how wonderful! But then you neglect the fact that every new layer can influence the properties of the existing ones, and so does the deposition process itself. And additionally, this is really very cumbersome. Just imagine how often you have to interrupt the production process for a system with 20 layers and more. And exactly that is why the new Calotte module is a really great innovation. It is the first and only tool worldwide with which you can determine a true realistic profile of the material's properties, instead of only taking average values. It is based on the calotte grinding, which is a cheap but effective process in which the material layer pile is, well, grinded such that a so-called grinding crater shows the different layers with all their thicknesses. Then a series of indentation test measurements is performed inside and outside this crater. The test series can be programmed easily with modern indentation devices and offers many advantages compared to simple vertical cut measurements. It is not very expensive, can be adjusted with ease on the indentation device that you already have at hand, and in the end you have a very good mapping, a true realistic profile, of the real sample containing material properties of the whole material combination. And here is how the SIO software Calotte module works. 3 or more indentation measurements are performed along the grinding crater. In this video animation, we have chosen 4 measurements for illustration only. You can see the loading and unloading process at first directly in the center of the crater. Then 2 tests are performed at the flank of the crater. Here we see how the stress inside the layer is built up slowly and then goes down again when the indenter is unloaded. In this animation we have chosen the von Mises stress, but the software calculates over 30 different field components at once, even customized if you like. These are many different stresses, strains, displacements, energy, distortion work, and so on. And finally, one more measurement is done on the surface. The software collects all data together with the depth and position information and processes them accordingly. This way, the software evaluates the true mechanical property profiles without any approximation. Thus, the correctness and resolution of the subsequent profiles only depends on the number of nano-indents. So here is now how it works in detail. The analysis is performed from the center of the crater to the outside rim. In this simple example in the picture here, we examine a 2-layer system with an interlayer, which here is named layer 1, and a top layer, called layer 2. We have performed 4 different measurements. 1 in the substrate, 1 in layer 1, and 2 in layer 2. After the performed measurement, the software stores 4 values for E. Es for the Young's modulus within the substrate, E1 for the Young's modulus within the first layer on top of the substrate. And let me remark one thing more. In an application for the automotive industry in diesel systems, it even was possible to go down to 80 nanometers and detect weak interfaces. The third analysis is E21 for the Young's modulus within the second layer, and E22 for the Young's modulus at a second point within the second layer. And be careful. In the case that E21 and E22 differ significantly, you should check if this layer really is monolithic. The measurement data point to something else. So, no matter what your coder tells you about the supposed to be homogeneity, the software shows what you really have, and obviously you here have an additional layer which should be added to your model. So, in conclusion, we might state that a combination of Calotte grinding and indentation testing offers a new and indeed very reliable and effective way to extract the material parameters of multi-layered materials. This method gives you generic material parameters of each part, as well as important hints about its structure. Both technologies are relatively cheap and easy to use, and you don't need an additional measurement device or other expensive analysis tools. Thank you very much for your attention. If you have any questions, please don't hesitate to ask us.